Hello Gators, this is 10-4 Inscribed Angles, Day 2. So in Day 1 we talked about inscribed angles. Inscribed angles are an angle who's made up of two chords and the vertex is on the circle. And we know that when you have that kind of inscribed angle, it's 1/2 the intercepted arc. Let's look at this situation. We have an inscribed angle right here. This angle right here is an inscribed angle, and it intercepts this arc right here. And this arc will be, this angle is half the intercepted arc, so this arc will be 220 degrees. Let me change color. Now, the remaining part of the circle is the rest of the circle. So if we take 360 and subtract 220, the rest of the circle is 140 degrees. Now let's see if we can figure out angle C. Angle C is half of the intercepted arc. So it'll be half of 140, which is 70 degrees. Now notice that angle A is 110, and notice that angle C is 70, and they add up to 180. And that makes sense because both angles are working with the whole circle, and half of a whole circle is 180. All right, that's our next theorem. And our next theorem says that when you have an inscribed quad, four-sided figure, then the opposite angles, that's this angle and this angle, will be supplementary. And so will angle U and angle S. Let's go ahead and find angle A. Remember, these are opposite angles. This is an inscribed quad, so these two angles have to add up to 180, which means this will have to be 715 degrees. 115 and 65 will make 180. These two angles will have to be supplementary, so that means this will be 60 degrees. Angle C and angle A are supplementary angles, so this angle will be 140 degrees. Let's take a look at another situation where we're taking a look at a tangent and a chord. So we're working with this tangent and this chord right here, and it is not an inscribed angle. Inscribed angles are made by two chords. This is a tangent and this is a chord. Let's call this angle right here x degrees. We'll say x. Now this is a diameter, and we know diameters cut circles in half. So this angle right in here will be 90 minus x. 90 minus x. And we know that 90 minus x, this angle, is going to be 1/2 of this arc right here. That's what this is saying. That angle is equal to 1/2. Now we're going to times everything through by 2, and we're going to get this. So now we have a way to write df. df is written this way. Let me change color, and let's talk about this arc right here. Oops, need to change color. And we'll talk about this arc right here, this blue arc right here. And we know that the red arc and this blue arc add up to the whole arc, which is 180 degrees. So we know these two arcs add up to 180. We know that df can be written this way right here. That's from up here. Now we're going to subtract 180 on both sides and move the 2x to the other side. And then we're going to substitute for x. We know that x is equal to this right here. So we're going to take x out and we're going to put this right here. And then we're going to divide by 2. So we're going to have measure of angle FHJ, which is this angle x right here. That's what we're trying to figure out. This is what our x was. And we have found that x is actually equal to 1/2 FGH, and FGH is this blue arc. So this angle x is half of the blue arc, so it's acting like an inscribed angle. And that's what the what we'll go ahead and do in this situation. So we know that arc AC is 88 degrees, and we want to figure out how big, I'll go ahead and put it in red. We want to figure out how big this angle is right here. And since that angle intercepts 88, we say that it's half. And so the answer is 44 degrees. Okay, let's talk about GFC, which is this angle. It's 115. And the question is, how big is this arc from F to A to C? And you can see that this angle intercepts this green arc. So this angle will be half the intercepted arc. So that means that intercepted arc will be 230, because 115 will be half of 230. And that's what the theorem says. The theorem says that if you have an angle formed by a tangent and a chord, that's this angle right here, will be 1/2 the intercepted arc. It'll be 1/2 of this arc right here. Let's go ahead and practice one more time. This angle is formed by a tangent and a chord, and I would like to find how big this arc is right here. Well, since the angle is 50, then the arc will be double that, 100 degrees. Now let's take a look at finding the measure of VXW. That's this angle right here. Now we know that this arc is 50, this arc is 196, so what's left for this arc right here? Let me go ahead and put it in red. Well, how many degrees are left? So we're going to take 360 and we're going to subtract this arc, this green arc, which was 100. And then we're going to subtract 196. So those are the measures of all the arcs. And then we're going to use a calculator. So the number of degrees in this arc is 64, and we want to find the angle. That angle will be half the intercepted arc, so the answer will be 32 degrees. And so now we're going to summarize the lesson. We have inscribed angles. We have an angle formed by a tangent and a chord, and it has the same formula.